Okay, today we're going to consider why you would want to complete the square, not how you do it. We've already looked at that. And there are a number of questions at secondary school level which this is a useful tool for completing. So find the minimum value of this expression. Complete the square. X plus 5 halves all squared take 7, but there's a positive 5 halves being squared here. That's a positive 25 quarters that we do not want. So let's subtract the 25 quarters. X plus 5 halves all squared, take 25 quarters, take, let's get a common denominator, that's going to be negative 28. And so we've got x plus 5 halves all squared, take 53 quarters, and the square has been completed. Now, the minimum value of this expression, let's think for a moment. When you square something, the smallest it can possibly be is 0. If we have a positive number and we square it, we'll get a positive. If we have a negative number and we square it, we'll still get a positive. So the smallest value which we can get in here is 0. 0 squared makes 0. Take 53 quarters. We cannot do anything about that negative 53 quarters. It's just there. So 0 take away 53 quarters is the smallest possible value that can come out of that calculation. And it happens when x is negative 5 halves. That's what will make that bracket have a total of 0. And so we have the minimum value of the expression. We'll come back to this in a moment. There's an equivalent question where you're asked to find the maximum value of an expression. Let's have a look at this one. This one's more complicated. We're going to have to take out a factor of negative 1 before we can go any further. And if we do that, then what we have is x take 3 all squared. There's a positive 9 hiding in here, which we don't want, so we'll subtract it. We've got negative x take 3 all squared take 5. And so if we re-expand, multiply through by minus 1, we've got negative, open a bracket, x minus 3 all squared plus 5. Now the question was, find the maximum value of this expression. The reasoning is similar to what we said over here. X minus 3 all squared. The smallest x minus 3 all squared can be is 0. But then it's being multiplied by a negative. So if this is something other than 0, if this bracket squared was 4, it will then be turned into a negative 4. It will be smaller. And we want the maximum value. So we actually still need this bracket squared to make 0. Because if it's not 0, then we'll be introducing a negative number which will reduce the value that we could otherwise have had. So we want this to be 0. The plus 5 we can't do anything about. And so the maximum value will be plus 5. And it will happen when x equals, well, when this bracket works out at 0, so when x is 3. The maximum value of this expression is 5. Now, there's something important going on here. Notice these two original questions. They're not graphical. There is no mention of y or a y-axis. But what we're going to do now is change the question slightly. suppose these had said y equals. And suppose instead of the minimum value, suppose instead the question had asked for the minimum point. And over here, it had asked for the maximum point. Well, now, these questions are talking about a curve on a graph. They weren't before. Y equals positive x squared. This curve, it's a quadratic, it definitely has that shape. We know this because of this positive x squared. And now you can start to see the minimum that the question is referring to. Over here, y equals negative x squared, the curve is definitely that way up. And again, you can start to see the maximum point that this question is talking about. You would go through exactly the same logic, but you would state your answer differently. The minimum point now is at an x value of negative 5/2 and a y value of negative 53/4. And over here, the maximum point will be at an x value of 3 and a y value of 5. So it's exactly the same logic, but when I was just working in black, it was just talking about numbers, it was just talking about values. As soon as I put y equals on the front and convert it from an expression to an equation, we can start thinking about it graphically, and we're starting to find a turning point on a graph. That is the first main use of completing a square. In the next video, we'll look at the next one.